Okay, so welcome back. After we discussed the logs, it's now a good time for us to get into topics and partitions. Okay, so we're now starting to look into Kafka architecture components. So I hope everything connects now and you'll be able to understand uh, how logs connect to topics. All right, so before getting into what is a topic, we can start with the question like, why do we need a topic? Okay. Imagine that in a production scenario, when you're developing an application, one log might not be enough for everything you want to accomplish. All right. So we need to be able to separate events that belongs to different domains. All right. That's kind of the similar concept as of database tables. Each category of the data will go into a table, right? So in our case, each category of data will go into a topic. So here on the schema concept of a database, you'll have you'll have your schema, and then you'll have your product table, your order table, your users table. That applies as well on the topic. So a topic, it's nothing more than a logical string of data of the same type. So just think of it as a named log. So we have your log, you put a name into it, and everything that you're going to send to this log, it's related to the same domain. So for example, similar to the table concepts here in our database, we'll have our topic products, and we'll have our topic orders, and we can also have our topic users that I don't have it represented here, but that follows the same concept. So inside the topic products, everything related to a product, all of the events, all of the records, all of the messages that are going to produce that are related to products goes into the products topic. And the same applies as well to the orders topic. All right. So quick note for us is that inside a Kafka cluster, we'll often have hundreds of thousands of topics. Okay, so have plenty of topics that'll where each microservice or data domain can publish and consume to its own topic. All right, so that separation of categories of data can keep our data organized, and it's very secure and easy to scale. So you put everything where it belongs. Okay, so that is what a topic. Think of it again as a named log where you just send events that pertains to a certain entity, you send it to the correspondent log. Now, before going into what is a partition inside a log, we need to have a quick view on sharding. All right. So if you're familiar with database systems, you know that sharding is the process of dividing a large database into smaller pieces that we call shards. All right. So each shard is stored on a separate database server, and we do this to improve the performance, scalability, and the availability of this data. So just think that if you have like a user's database, you can split that data into one shard here that will be stored somewhere where you just have the names inside the users from A to H, you put here. Everything that goes from I to Q, you put there in a different shard, and everything you put uh, in the shard C corresponds to names from R to Z. Now, there are many algorithms that we can use for deciding which record goes to which shard, but are not going that deep in this lesson. Okay, but this is applied to the database. In the Kafka world, what I need to understand that sharding refers to dividing a topic into smaller ordered logs that are going to call partitions. All right. So what are the partition? Partition is nothing more than an independent log that is stored and replicated across brokers. We're going to brokers in the next lesson, but imagine as a broker as a server inside a cluster. Okay, so partition is independent, and we're going to store it and replicate across different brokers. And why we use it? Because it allows the same topic that contains certain events of a certain category to scale horizontally. All right, so you can put it into different brokers. A topic can have just one partition, that's true, but that's not common because this scalability, we want to achieve that, right? So generally we have dozens of partitions for the same topic. So if we look here into this representation of a cluster, say we have two brokers or two servers inside the cluster, and we have a topic A, we have a partition 0, topic A, we have partition 1, and another broker, topic A, partition 0, and topic A, partition 1. Okay, so we see that we have different partitions for that topic spread across different brokers. Let's talk about some characteristics of partitions. All right, so each partition will store its own ordered logs of records. All right, so we can see here in partition 0 we have, for the topic orders, we have order 0, 1, 2, and 3, while in the partition 1 we go to 3 only. Here we have more than that, so they're independent. All right, each one of them will store its own ordered log of records. Each one of them as well has offset starting from 0. So you can see the partition 0 starts from 0. The partition 1 also starts from 0. All right. They can be read and written independently. So you can write to the partition 0, and you can read from the partition 0 independently of the write to the partition 1 and read from the partition 1. Okay, the more partitions you have, the more scalability you achieve, right? Of course, there are trade-offs you need to make, but that's like a basic rule. Okay, one thing that is very important, the ordering is only guaranteed inside each partition, not across the entire topic. Okay, so if you look inside the partition 1 for the topic orders, they are ordered. This you can say that it's guaranteed, the ordering. Similar to the partition 0 here, you can guarantee that order, but you can't guarantee the order across the entire topic in a Kafka topic. Okay, so just for us to summarize, a topic is a collection of partitions. All right, the topics can organize your data in different domains. That's the purpose. And the partitions will make your data scale because it can be stored into different brokers or servers where you can achieve that horizontal scalability. All right, so hope it's all clear, and see you on the next lesson.